We're going to be looking at different types of logarithms today, mostly common and natural logarithms. Common logarithms are base 10, and we write it without the base. Mathematicians like to use natural logarithms, which are with base e, and we write that with just ln. And both of those buttons are on your calculator, the main buttons on your calculator. Computer scientists work in binary, so they use base 2, which is abbreviated LG. And that's just kind of thrown in there just to give you a heads up for those of you who are computer science majors, but we're really not going to be doing much of anything with base 2 in college algebra. Now, these first 4 problems here are asking us to evaluate each of the following without a calculator. Remember that this means log base 10, even though the base is not written there, it's understood to be base 10 of 10 to the 5th power. So what power do I need to raise 10 to get 10 to the 5th power? We need to raise it to the power of 5. Similar thing here, my answer is going to be -2. This is saying what power do I need to raise e to get e to the 4th power? The answer is 4. And here the answer is going to be -3. Now the next set of problems are asking us to evaluate each of the following with a calculator and rounding to 4 decimal places. So you should be able to look at your owner's manual on your calculator if you're not sure how to do that. So go ahead and pause the video and try to get those answers and come back and check them. Okay, and there are answers for those next 4 problems. Okay, this next part is looking at finding values of logarithms when the base is not 10 or e. And your calculator has a built-in function for evaluating these logarithms if you have the updated operating system. You can find the answer to these problems without having to do a change of base formula. Now, the change of base formula we're going to talk about down here in a minute. So depending on what type of calculator you have, you may not need to know how to do this on a test, but it is something that is useful for you to use when you're looking at upper level math courses. All right, so using your built-in function or your change of base formula, evaluate each of the following with a calculator. So access math, and then just scroll down to log base, and then you can enter your base and your argument here and get the answers. So let me give you a minute to put those problems into the calculator and see what answers you get. Okay, there are your answers for that part. And for the next part is looking at the change of base formula. And this formula, again, this is one of those things that looks a little bit more confusing than it really is. And the change of base formula was really used more so because we just didn't have the technology that would do this for us. Even as long as maybe 15 years ago when the TI-84s first came out, it did not have these log-based functions available to it. You had to use the change of base formula. And it's really not that bad. What this is saying is that you have the log of 8, remember this is common log, divided by the log of 5. So the 8 is the bigger one, it's kind of up on top, and the base is the 5, it's kind of down on bottom. So if you could put that into the calculator, that's the same as log base 5 of 8. And that's going to be approximately 1.2920. So let me give you a minute to try to finish those other 3 and see what you get. Okay, there are your answers for those 4 problems. Now, problem 16, I don't know why that they had this type of problem in the book, but this problem is something that really does not lend itself to a change of base formula. This is just a natural log. And other thing I do want to mention about the change of base formula is the proof of this formula is in your textbook.